Hello everyone, welcome to my YouTube channel. This is the problem on truss elements. For the 3-bar truss as shown in figure, determine the displacement in the node 1. Determine the displacements in node 1 and the stresses in the element. Take area of each element is 250 mm square and Young's modulus is 200 gigapascal. Here, this is the figure. This is the truss element given in this problem. Here, there is a 3 supports at node 2, node 3 and node 4 and pivot point at node 1. And at node 1 there is a load of 18 kilonewtons acting vertically downwards direction. Okay, the vertical distance between the node 1 and node 2 is 600 mm. The horizontal distance is 450 mm. Similarly, the supports, the distance from the node 1 and node 3 and node 4 is 350 and 450 mm respectively. Okay, here the length of the each truss is not given in this problem. By using the vertical length and horizontal length using Pythagoras theorem or rule, you calculate the length values. Here, based on these two values, the length of first element is 750 mm. Similarly, second element is 1000 mm. Third element is 750 mm. Okay, here at node 1 there is a displacements of q1 and q2, and at node 2 q3 q4, at node 3 q5 q6, at node 4 q7 q8. Okay, these are the displacements. Each odd number indicates the horizontal displacement and the even number indicates the vertical displacement of each node. First of all, you have to write the element connectivity table. Here in this diagram we are having the nodal 3 truss elements, 1 2 3. These are the 3 truss elements. So you have to indicate the 3 truss elements. Then 1 and 2 nodes 1 and 2 indicate the starting node of the each truss and ending node of the each truss. Okay, for the first element starting node is 1 and ending node is 2. Similarly, second element starting node is 1, ending node is 3. Third 1 and 4. Okay, here this is the first element, starting node is 1, ending node is 2. Similarly, second element starting node is 1, ending node is 3. Next, third element starting node is 1, ending node is 4. Okay, then after that nodal points table, you have to indicate the nodal points. Here taken, this is the origin 0 comma 0. Here this is the left side along x direction means negative, minus 450 comma vertical distance is 600, 450 comma 600. Here in this place horizontal distance is 450 plus 350, total 800 comma the vertical distance is 600. Okay, similarly here 450 comma 600. These are the coordinates of each node. You indicate the each node coordinates of the each node. First node 0 comma 0, second node minus 450 comma 600, third node 800 comma 600, fourth node 450 comma 600. Okay, after that you have to find out the direction cosine table. Direction cosine table. Here this is the element number 1 2 3. This is the c value. C means x2 minus x1 by l. L means length of the element. X1 and x2 values taken from this table based upon the truss element. Okay, this is the s value, y2 minus y1 by l. Okay, for the first element having the nodal numbers 1 and 2. Here 1 and 2. This is the x2 value, this is the x1 value. Minus 450 by minus 0 means minus 450 by length of first element is 750 mm. Minus 450 by 750 means minus 0.6. Similarly, y2 minus y1, 600 minus 0 means 600 by length of the element gives the 0.8 value. For the second element having the nodal numbers 1 and 3. Here 1 and 3. 3 is the second means x2 value, 1 is the x1 value. X2 means x1 by length of element is 1000. Similarly, y2 means y1 by length of the element. Similarly, third element having the nodal numbers 1 and 4. 1 and 4, 1 and 4, 450 minus 0 by length gives the c value. 600 minus 0 by length gives the s value. Okay, this is the direction quotient table. After finding out the direction quotient table, you have to find out the element stiffness matrix for the truss elements, each truss elements. Here the K formula is K equal to AE by L. Here formula C square CS minus C square minus S, CS C square minus CS, S square minus S minus S square minus S minus S square minus C minus C square CS CS S square. This matrix is easily understand. Follow this rule. AE by L. Okay, open the matrices. Okay, then first of all you write c square and cs. Okay, remember this two. Then these two are having the positive signs. Next you have to write minus c square minus cs. Okay, minus c square minus c. Then the first row is written as first column, cs minus c square minus cs. Okay, first row is same as the second row, say first column. Now here you have to write s square. Okay, these two are having the positive sign. You have to indicate this is negative sign, minus cs minus s square. Next, second row written as a second column, minus cs minus s square. Second row is equal to second column. Okay, similarly these two are having the negative signs converted into positive signs, c square cs. Similarly, this third row written as third column, so you have to indicate the cs. Here these are the two negative signs, here positive, then s square. This is a matrix you have to remember in this way. Okay, it is easy to remember. After that, this is the first element, the area and Young's modulus and length of the each element given in the problem. Similarly, the matrices, the values of c and s are taken from the direction quotient table and substitute in the matrix. Okay, after solving this entire thing, you got the value of 10 power 8 and the matrix like this. The first node, first element having the nodal, the first element having the nodal numbers 1 and 2. At node 1 and node 2 having the displacements of 1 2 3 4. Okay, so you have to indicate the 1 2 3 4 1 2 3 4 right side and top side of the matrix. This is the K1 matrix. You have to remember this is the K1 matrix. After finding the K1 matrix, you have to find the K2 matrix. Similarly, the same method, you have to substitute the C and S values corresponding to second truss elements, and A and length values are given in the problem. So you have to calculate this entire thing. You got the matrix like this. Okay, this is the K2 matrix. But here the truss element, second truss element having the nodal numbers 1 and 3. The displacements at node 1 and node 3 are 1 2 5 6. So you have to indicate 1 2 5 6 1 2 5 6 right side and top side of the matrix. Similarly, K3 also you have to calculate the K3 also. Then you got the K3 matrix like this. Okay, this is the K3 matrix. After substituting the C value and S values, you calculate this entire thing. You got this matrix, final K3 matrix. Here the nodal numbers for the third truss elements is 1 and 4. The nodes are 1 and 4. Down at node 1 there is a 2 displacements of 1 and 2, and at node 4 there is a 2 displacements of 7 and 8. So you have to indicate 1 2 7 8 at top and right side of the matrix. After finding out the K1, K2, K3 matrix, you have to find the global stiffness matrix. Global stiffness matrix K equal K1 plus K2 plus K3. This is the K1 matrix. This is the K2 matrix, and this is a K3 matrix. You got this 3 matrix earlier step. Okay, add this add all these matrices, you got the one combined matrix. Okay, here 10 power 8, 10 power 8, 10 power 8 is common, so you have to keep 10 power 8 outside and open the matrix. You first of all you keep 1 to 8, 1 to 8 nodal numbers at top and right side of the matrix, then fill it this entire matrix with the help of these three values. Okay, for example here, first column, first row, first column, first row. Here first column, first row having the 0.23 plus, here first row, first column having 0.32 plus, first column, first row having 0.24, 2.24, 0.23 plus 0.32. Combine these three values, you will got the 0.79. Similarly all this matrix filled with by using the above three matrices. After finding out the global stiffness matrix, you have to find out the global load vector. Global load vector F equals sigma Fe plus sigma Te plus sigma P. Here there is no body force, so keep 0. There is no tractive force, so keep 0. P, point load. In this diagram or figure, the point load acting at node 1 in the direction of q downwards, vertically downward. Vertical displacement means q2. This is the downward direction, so you keep it as a negative load of 18 kilonewton. Similarly at node 2 and node 3, node 4 there is no load, so you keep F equal to 0 at node 2, node 3, node 4. Okay, at node 1, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8. These are the displacements at node 1, node 2, node 3, node 4 respectively. At node 1, there is no load along the Q1 direction, so keep 0. At node 2, at node 1, there is a load along the vertical direction, means q2 direction in downward direction, so you keep negative. Remaining all nodes there is no load, so keep all zeros. This is the F matrix. From Rayleigh-Rich method, you know kq equal to F formula. Here k matrix you got kq equal to F. Find that is obtained from the Rayleigh-Rich method, but in this problem we solve by using the elimination approach. Okay, in this problem there is a supports at node 2, node 3, node 4, so the displacements at node 2, node 3, node 4 is 3, 4, 5, 6, 7, 8 respectively. So you have to eliminate the 3, 4, 5, 6, 7, 8 rows as well as columns. So third column, fourth column, fifth column, sixth column, seventh column, eighth column. Okay, similarly third row, fourth row, fifth row, sixth row, seventh row, eighth row also. The remaining value, what is the value remaining? 0.79, 0.24, 0.24, 1.02 into 10 power 8. This is the K matrix. So you have to indicate the remaining matrix after cancellation of the rows and columns corresponding to the supports. Okay, the corresponding displacements are at node 1, Q1, Q2. Okay, then F values 1 and 2 only you have to take. Remaining rows are cancelled. Okay, so you have to put these two values. After that, keep 10 power 8 RHS side, then it will become 10 power minus 8. So you multiply these two matrices, you will got these two equations. Solve these two equations by using calculator. You got the Q1 value of 5.77 into 10 power minus 5 meter, Q2 equal minus 1.90 into 10 power minus 4 meter. Next, stresses in each element. Sigma equal to E by L minus C minus S C S Q. Here E by L1 minus C minus S C S Q1 Q2 This is the element number 1 having the nodal numbers 1 and 2, having the displacement q1 q2 q3 q4. So you have to mention q1 q2 q3 q4 here. Substitute all the values. Q3 q4 are 0, q1 q2 just you obtain in the above step. So you multiply these two matrices, you will got this equation. Calculate this entire thing, you will got the sigma 1 value is 49.63 MPa, okay, megapascal. Similarly, sigma 2 E by L2 minus C minus S CS, here having the displacement 1 2 at node 1 and 5 6 at node 3. Okay, this is the second truss element displacements. Okay, substitute the all the values and calculate, you got the 13.6 megapascal as the stress in the second truss element. Similarly, calculate the stress 3. Sigma 3 at truss element, third truss element. Sigma 3 equal to E by L3 minus C minus CS. Q1, Q2 are the node 1 and Q7, Q8 are the node 4. The node 1 and node 2 are the nodal numbers of the third element. So substitute all the known values and calculate the sigma 3 value. Then you will got the 31.22 megapascal as a stress in the third element. Okay guys, this is the problem on truss elements. This is the most important and many times asked in or several times asked in examinations. Okay guys, please subscribe my channel, share the share this into the share this to your friends and like this video. Thank you for watching. Thank you.